Hey, Mr. Lee, thanks so much for joining the Discord. Shout out to you. Appreciate you joining the Discord, and let me know how you like it, and if you would like to see any more or any additional resources, or let me know. Yeah, thank you so much, and enjoy. Yeah, it's everything I've used so far to teach myself, and I'll keep adding on to it as I go here. So, awesome. Hello, Mr. Mon. Hello, Kaluza. Let me run to the restroom really quick and we'll go ahead and jump into today's stream. Let me go to the bathroom right quick and I'll be right back. BRB. Let me go to the bathroom. Alright, hello everybody. Welcome back into the stream. I hope you're having a wonderful day so far. I appreciate everybody for being here and welcome back in today. I hope everybody is having enjoyed a good Sunday. Hello Rashab, welcome back in, dude. First like, thanks for the like. I appreciate you. Appreciate you so much. Okay, let's go ahead and get started for today. So today I'm going to quickly just test a recording really quick because I recorded some Python crash course videos and they did not work. So I'm going to make sure my recording is working. So test, yada, yada, yada. Let's record like 10 or so seconds here and then we'll make sure that it's working. So stop. Okay, remix. There it goes. Okay, now let me see here. Unfortunately, I'm going to have to re-record my 2 Python crash course videos. It really sucks. Alright, yeah, it's working. Yeah, like something happened with the file, it like corrupted, and all of a sudden it was glitching, and yeah, it was bad. So super unfortunate. I'll have to re-record those. Sad. But I appreciate you guys for joining me here. Welcome, welcome, welcome. We are going to be jumping back into MIT today, as we usually do, or back into our courses here. So let me go ahead and start the official recording for today. All right. Alrighty, welcome back in, everybody. I hope you're having a wonderful day so far. My name is Michael, and welcome back to the channel. We're going to be jumping back into MIT OpenCourseware 6.0002 from fall 2016, the Introduction to Computational Thinking and Data Science course. We are on Lecture 5, Random Walks, with John Butog today. We're going to be discussing how to build simulations and plot graphs in Python. So this is going to be a great lecture, and if you guys have missed the previous lectures or are wanting to follow along, I'm uploading these as a series to my channel as a re-upload watch-along series, as well as you can catch this live right now. Hello to those that are here live and watching this. I stream every single day around 7 p.m. PST after my 9-to-5 job as a chemist. So we are going to continue on here with the course, teaching ourselves computer science every single day. Cool. I hope everybody is enjoying today and ready to learn. I am ready and I'm feeling good. So let's go ahead and get into these lectures. They're only like 15 minutes long, so they're not too bad. Really not bad at all. And yeah, it should be good. Okay, so we left off on lecture 4 yesterday. Let's go ahead and get into lecture 5. Lecture 5 notes dot marked down. Here we go. And let's do lecture 5, random walks, right? Cool. All right, let me know how the volume is, everybody, and let's go ahead and get on into this lecture for today. Welcome in, everybody.
The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Let's get into this.
All right. Today we're starting a new topic, but it is, of course, related to previous topics. As usual, if you go to either the 60002 or the 600 website, you'll find both today's PowerPoint and today's Python. You'll discover if you look at the Python file that there's quite a lot of code in there. And I'll be talking only about some of it, but it's probably all worth looking at, and a fair amount of reading associated with this week. All right, why are we looking at random walks?
Hey, Austin, how's it going, my guy?
Picture here of, think of them as molecules just bouncing around. This is actually a picture of what's called Brownian motion, though Robert Brown probably did not discover it.
Okay, why random walks?
We're looking at random walks because Well, first of all, they're important. In many domains, there are people who will argue, for example, that the movement of prices in the stock market is best modeled as a random walk. There's a very popular book called The Random Walk Down Wall Street that made this argument. And a lot of modern portfolio analysis is based upon that. Those of you who are not interested in making money, and I presume that's most of you, it's also very important in many physical processes. We use random walk, say, to model diffusion, heat diffusion, or the diffusion of molecules in suspension, et cetera. So they're very important in a lot of scientific and indeed social disciplines.
Nice.
They're not the only important thing, so why are we looking at those? Because I think it provides a really good illustration of how we can use simulation to understand the world around us. And it does give me an excuse to cover some important topics related to programming. You'll remember that one of the subtexts of the course is, while I'm covering a lot of what you might think of as abstract material, we're using it as an excuse to teach more about programming and software engineering, a little practice with classes and subclassing, and we're going to also look at producing plots.
Okay.
All right.
Drunkard's walk.
So the first random walk I want to look at is actually not a diffusion process of the stock market, but an actual walk. So imagine that you've got a field which has somehow inexplicably been mown to look like a piece of graph paper, and you've got a drunk sort of wandering around the field, taking the step every once in a while in some random direction. We can then ask the question, is there an interesting relationship between the number of steps the drunk takes and how far the drunk is from the origin at the end of those steps? You could imagine that if the drunk takes more steps, he's ever further from the origin. Or maybe you could imagine, since it's random, that he just wanders away and he wanders back in all directions and more or less never gets very far.
Yeah.
So just out of curiosity, I'll take a poll. Who thinks that the drunk doesn't much matter how many steps he takes, he'll be more or less the same distance away? And who thinks the more steps he takes, the further away he's likely to be?
Yeah, I think it's just going to kind of, he'll be closer to where he started.
When you take polls, they come out almost tied.
I don't think he'll get very far.
All right. So let's look at a small example. Suppose he takes one step only. Well, if he takes one step, he could, and we'll assume for simplicity that he's not so drunk that he moves at random. He either moves north or south, east or west.
They changed the pictures.
These are all the places he can get to in one step. What they have in common is that after one step, the drunk is always exactly 1 unit away from the origin. Well, how about after 2 steps?
It could be 2,
so
or it could be back at the origin.
So without loss of generality, let's assume that the first step,
or 1 step away.
Let me use the pen that you're supposed to use to write on this, rather than this pen, which would make a real mess on my screen. Without loss of generality, we'll assume that the drunk is there after 1 step. Took 1 step to the east. Well, after 2 steps, those are all the possible places he could be. So on average, how far is the drunk from the origin? Well, if we look, he could either be 2 steps away if he took another step east, 0 steps away if he took a step west, or what do we see for the top 2? Well, the top and the bottom one, we can go back and use the Pythagorean theorem. C squared equals a squared plus b squared.
Yeah.
And that will tell us that it'll be the square root of a squared plus b squared. And that will tell us how far away the upper 2 are. And then we can just average them and get a distance. And as we can see, on average, the drunk will be a little bit further away after 2 steps than after 1 step. Well, How about after 100,000 steps? It would be a little bit tedious to go through the case analysis I just did, right? There are a lot of cases after 100,000 steps. So we end up resorting to a simulation.
Nicely.
So we'll
Python
structure
is
it
my
exactly the same way we've been
kind of main
structuring our other
language, yeah.
simulations. We're going to simulate one walk of k steps, n such walks, and then report the average distance from the origin of the n walks. Before we do that, in line with the
So one
software
walk of
engineering
k steps,
theme
you're going
of
to
the
do a bunch of
course,
different walks and
we'll
report the average.
start by defining some useful abstractions. The three of them I want to look at: location, the field that the drunk is in, and the drunk, him or herself. All right, so let's first look at location. This is going to be an immutable type.
Yeah.
So what we see here, as long as I can't point on the screen, I'll point with a pointer, is that
You have
we'll
x and y are
initiate it,
floats,
we'll
so
initialize
there's
it
just
to
the location
an
x and y values.
That makes sense. We'll be able to have two getters, get x and get y. And here's how we see it's immutable.
Then you return
What
a new
move
location
is doing
on
is
a
it's
move.
not changing the location, it's returning a new location.
A new location, yep.
Perhaps move is poor choice of name for that, but that is what it's doing. It's just returning a new location where it adds the change in x and the change in y to get two new xy values. Notice, by the way, that I'm not restricting these to be integers or 1 or anything like that. So this would work even if I did not want to take those nice little east-west, north-south steps. I've got a underbar string, str, and then here's my implementation. You can see it's very sophisticated, of the Pythagorean theorem. So I just do it that way, and that will give me the distance between two things. It's one of the annoying things about classes, in actually all languages I know with classes, is you would like to think that self and other, there's a symmetry here. The distance from self to other is the same as from other to self, but syntactically, because of the way the language is structured, we treat them a little bit differently. All right. How about class drunk? Well, this is kind of boring.
Just
Drunk is a name and
if
a
no
string.
name, return anonymous.
And that's all. Well, the point of this, and I don't think we've looked at this before, is this is not intended to be a useful class on its own. It's what we call a base class. The notion here is its only purpose is to be inherited. Okay, it's not supposed to be useful on itself, but it does give me something that will be used for the two subclasses. And we'll look at two subclasses, the so-called usual drunk, the one I tried to simulate when I was wandering around, who wanders around at random, and a drunk I like to think of as a New Englander, or a masochistic drunk, who tries forever to move ever northward because he or she wants to be frozen. I do like this picture of entering the state of Maine in the winter.
Shout out Maine, shout out all the frozen.
So here's the usual drunk, subclass of drunk, and it can take steps at random, one step, either increasing y,
take step it
north,
can increase,
decreasing y,
you
a
turn
step
a
south,
random step.
increasing x, a step east, or decreasing x, a step west. So those are the choices, and it's going to return one of those at random. I think we saw random.choice
This one goes
in the last
upward,
lecture.
this one goes down.
And then our masochistic
left,
drunk, it's
right and
almost
left.
the same, except the choices are slightly different. If he chooses to head north, he doesn't go one step, he goes 1.1 steps north.
You go
If
south.
he chooses to go south, he only goes 9/10 of a step. So what we're seeing here is what's called a biased random walk. And the bias here is the direction of the walk
northward bound, yeah.
that is moving either up or down.
You have a absolute
Okay.
sum of positive
Pretty simple.
In the north direction for this step.
How about just to test things out, we'll ask the question, is this an immutable or immutable type? Are drunks mutable or immutable? This is sort of a deep philosophical question.
Well,
right?
you can mute
but
a
if we
chunk,
ignore the philosophical underpinnings of that question,
probably not.
What about the two types here? Who thinks it's immutable?
I'm going to say it is
Who thinks it's mutable?
immutable.
All right. Why do you think it's mutable? What's getting changed? The answer is nothing, right?
Clutch. Yes.
It gets created.
It's immutable. Phew!
And then it's returning
Just a random
the
choice
step,
of preset
but it's
values.
not actually changing the drunk. So far we have two things that are immutable, drunks and locations.
Look at us. Let's go.
Let's look at fields. Fields are a little bit more complicated.
Okay.
So
we have a drunk dictionary. So we're going to add a drunk to the dictionary,
and the dictionary
with a drunk and
is
its
going to map
location.
a drunk to his or her location in the
And then
field.
the get location just gets the
So we
location
can
from
add
the key of the drunk.
a drunk
Okay.
at some location.
Easy. Very
And
easy.
we're going to check. And if the drunk is already there, we're not going to put the drunk in. We're going to raise a value error, duplicate drunks. Otherwise, we're going to set the value of drunk in this mapping to loc. And now you see, by the way, why I wanted drunks to be immutable. Because they have to be hashable so I can use them as a key in a dictionary. So
Yeah.
it's not an idle question whether they were immutable. It was an important question. I can get the location of a drunk. If the drunk is not in there, then I'll raise a different value error, drunk not in field. Otherwise, I'll return the location associated with that drunk.
Yeah. Now we have a move drunk, which takes the
And
drunk.
finally,
if drunk not in
We're
self
going
drunk,
to
so
have
you raise a value
move
error.
drunk.
You take step,
Again, I'll check
returning its
whether
x
the
and y
drunk is there.
distance of the drunk.
If the drunk is there,
And
I'm
then
going
you
to get
move
the
by those
distance
x and y distance.
on x and the distance in
So
y
you get the random step,
by
right?
calling drunk.takeStep.
Which is that method that takes
All
a
right,
step,
so we saw
or
a take
depending
step
on which
for a
drunk.
drunk didn't move the drunk anywhere because the drunks were immutable, but returned
The
new
step it
locations,
took it,
so
right?
new x and new values, and
I
then
think
I'm
it
going to
changed-
use that
It changed updated values, like
to
delta
move
values.
the drunk in the field.
And then you add,
Okay?
you call move, which
So I
adds
said
those delta values
self.drunk from
onto
drunk
its
to
current
move
location.
x distance and y distance. All right? So it's very simple.
Yeah, here's
But
the
having
deltas.
built
Yeah,
these-
you take the deltas and apply
This
those
set of
to the x and the
classes,
y.
we can now actually write the simulation. Oh, what about classes? Are they mutable or immutable? Not classes. What about fields? Any votes for mutable?
You mutate the drunk
Yeah,
variables.
exactly.
Yeah.
Because you can see I'm mutating it right here. I'm
Yeah.
changing the value of the dictionary. And in fact, every time I add a drunk to the field, I'm changing the value of the dictionary, which is to say mutating the field.
Yeah.
So I'll have a bunch of locations which are immutable objects. Makes sense that a location is immutable. A bunch of drunks, and the thing I'm going to change is where the drunks are in the field.
Yep.
All right? I said we'd start by simulating a single walk. So here it is, a walk in a field
Given a drunk with a number of
with
steps.
a drunk, and that drunk will take some number of steps in the field.
So you start at field get location of the drunk.
And you
For
can
every
see this,
step in
it's
the number
very
of
simple.
steps
I
you
just have a
move the
loop.
drunk.
Drunk takes some number of random steps.
You field dot
and
move
I'm going
drunk.
to return
and then you return the distance,
from the start.
right. You just make
to
running a
the final
simulation
location of the
across
drunk.
a single drunk, right?
All right, so how far is the drunk from the origin? I then need to simulate multiple walks. Notice
Multiple
here
walks.
that I've got the number of steps, the number of trials, and
So number of steps
D
and now the
class
number of
stands
trials.
for class of the drunk. And that's because I want to use the same function to simulate as many different kinds of drunks as I care about. We've only seen two here, the masochistic drunk and the usual drunk, but you can imagine many other kinds as well.
Yeah.
So let's do it. So here I'm going to simulate a walk for one drunk, Homer. So we'll create a drunk named Homer, or the variable
And its
Homer.
location is at 0, 0.
The drunk class.
For a number of trials, you create a
And the
field
origin.
and you add a drunk, and then you do
Distances.
distance append, and you
And
call
for
a
t and
round
range
of a
number
walk,
of trials,
right?
we'll
And then
just
one step.
do it, and then we'll return the distances. So it's initialized to the empty list. So we're going to return a list of, for however many trials we do, how far the drunk ended up from the
This
origin.
is the round. One's on the
Then
round.
we can
number of
average
trials
that, and we look
is
at the mean.
reused
Maybe we'll
here
look at the min or the max.
as the number of
Lots
walks
of
to do
different
per
questions
trial.
we could ask about the behavior.
Okay.
And now we can put it all together here. So drunk test will take the length, a set of different walk lengths, a list of different walk lengths, the number of trials and the class. And for number of steps in walk lengths, distances will be sim walks of number of steps, numbers, trials,
Okay, so
d-class.
for number of steps in the walk lengths,
And then I'm going to just print some statistics.
right, we're going to sim walks.
You may or may not have seen this. This is something that's sort of built in to Python.
Gotcha.
I can ask for the name of a class.
Gunning. Jeez.
So D class, you remember, is a class,
Come on,
and
Mike, wake up.
underbar name will give me the name of the class. Might be usual, it might be drunk in this case. Okay?
Okay.
So let's try it.
Let's try it.
All right, so the code we've looked at. So let's go down here and we'll run it, and we'll try it for walks of 10, 100, 1,000, and 10,000 steps, and we'll do 100 trials.
Why do I keep yawning? Oh my gosh. Come on. Wake up. Come on.
All right, here's what we got. So my question to you is, does this look plausible?
Does this look plausible? Right, so usual drunk
Is
walks
this-
10 steps.
What is it telling us here? Well,
The
it's
maximum
telling us
drunk
here
got
that
here.
the length of the walk actually doesn't really affect, the number of steps doesn't affect how far the drunk
Means
gets.
pretty consistent.
Yeah, there's some randomness, 8.6, 8.57, 9.2, 8.7. Not much variance.
Yeah.
So we've done the simulation and we've learned something.
Man, I gotta stop yawning.
Maybe. So does this look plausible? We can look at it here.
Even for 1,000 steps, he
transcribed
never
it.
really gets too far.
What do you think? Well, go
Even
ahead.
10,000 steps, you know, it doesn't. You kind of it doesn't change.
After the first two steps, there's like a 50% chance of going closer to the origin.
Right.
50% chance of going away.
So we have at least one vote for plausible, and it's certainly a plausible argument.
Is this kind of like the leak code problem that we were discussing? You know, the medium one that we did not too long ago, where it is like the first person on a plane forgets their ticket. Like, what is the likelihood or odds that, you know, every other, you know, at the nth person or the ith person given will also, you know, sit in their seat or have to sit in a random seat, right? It's kind of, I think it's kind of like that.
Argument. Well, one of the things we need to learn to do is whenever we build a simulation, we need to do what I call a sanity check to see whether or not the simulation actually makes sense. So if we're going to do a sanity
really
check,
excited
what
about
might
this.
we do in this case?
He's really excited.
We should
Let's try
try
it.
it on cases where we
We know
think
the
we
answer.
know the answer. Right? So we say, all right, let's take a really simple case where we're pretty sure we know what the answer is.
So
Let's run our simulation and make sure it gives us the right answer for this simple case. So
Walking
if we think of a sanity check here, maybe we should look at these numbers. We just did it. We know how far the drunk should get in 0 steps. Right? How far should the drunk move in 0 steps? 0.
0.
How far should the drunk move in 1 steps? We know that should be 1. 2 steps, well, we knew what that should be. Well, if I run this sanity check, these are the numbers I get.
You shouldn't have been able to move
I
with
should
0
be
steps.
pretty suspicious. I should also be suspicious. They're kind of the same numbers I got for like 10,000 steps. What should I think about? I should think that maybe there's a bug in my code. So if we now go back and look at the code, yes,
Hey,
this
Purple
is Bill's
Vision.
the pants on fire test.
Yeah, pretty much we're following the MIT
That there's clearly
6002
something
course
wrong
right
with
now.
these
We're on
numbers.
lecture 5, random walks.
What we were appending is walk of Homer num trials 1. Well, num trials is a constant. It's always 100.
Yeah.
What I intended to write here was not num trials, but num steps. But it was, you know, I actually did this the first time I wrote this simulation many years ago. I made this typo, if you will, and I got these bizarre answers. So I looked at the code and I said, well, that's actually wrong. No wonder it's always the same number. I'm calling it with a
calling for
constant.
the same number of trials
The
every
constant
single
happens
time.
to be 100. So let's go fix the simulation.
So you're only walking on that same constant. Yeah. Zooming in here.
So this should have been. Now let's run it again.
All right. 89,
Well,
27,
these
8,
results are
and
pretty different.
2.8. Yeah, so it gets dramatically
Now
bigger.
we see that, in fact, they're increasing. Should I just look at this and be happy? Probably not, right? I should run my sanity check again and make sure I get the right results for 0, 1, and 2. So let's go back and do
you can
that.
see that now
just to
that he
be a little
changed that, you
bit
can see
safe.
kind of this increasing first step increase.
So I'll just change
And
this
same
tuple
with
of
the,
values to be.
The other type of drunk. Well, he actually comes downward in on 1,000 steps.
And I should feel a lot better about this, right? All right, the mean, the max, and the min are all 0 when he doesn't take any steps. 1 is exactly what we should expect.
1 and 1.
And 2 is also, the mean is where we would guess it to be. And the max is 2, happened to take 2 steps in the same direction. And the min is 0, happened to end up where he started. So I've passed my sanity check. Doesn't mean my simulation is right, but at least I have reason to be hopeful. So,
Yeah.
all right, getting back.
Okay. Let's visualize the trend now with some matplotlib here.
So we
Yeah.
saw these results. And now we're getting the indication that, in fact, contrary to what we might have thought, it does appear to be that the more steps the drunk takes,
Hey,
further
Jow, how's it
away the
going?
drunk
Welcome
ends
back in,
up.
my guy. Welcome in.
And that was the usual drunk. We can try the masochistic drunk, and then we see something pretty interesting.
There's 1,000 steps here.
I won't make you sit through it, but when we run it, here are the usual drunks, the numbers, and I just looked at it for 1,000 and 10,000, so it would fit on the screen. You see for the usual drunk, it's 26.8, 90, roughly 90, fair dispersion in the min and the max. And the masochistic drunk seems to be making considerably more progress than the usual drunk. So what we see is this bias actually appears to be changing the distance.
Yeah, because this one has that northward bias, right?
Well, that's kind of interesting. Now we could ask the question, why? what's going on. And to do that, I want to go and start visualizing what's the trend. So rather than just looking at 2 numbers or n 3 numbers as we've been doing, I'm going to draw a pretty picture.
Yeah.
Actually, I'm not going to draw. I'm a terrible artist. But Python will draw some pretty pictures. We're going to simulate walks of multiple lengths for each kind of drunk, and then plot the distance at the end of each length walk for each kind of drunk. All right, I now digress for a moment to talk about how we do plotting. So we're going to use something called Pylab. I've listed here
Pylab.
4 really important libraries.
No, Mahan, I'm following. So what's going on so far is he's just doing, it's very similar to what we've kind of done in our projects. We've kind of already, naturally done this as like a scientist, I guess, with I think our science background. For those that are new here, I have a degree in human biology and a minor in chemistry. Get out of here. And so I kind of have like an idea of having, worked with some simulations and experiments in the past and using kind of, tailored data to, prove feasibility or like proof of concept of experiment before you kind of expand out to more theoretical bounds. And so this is it's pretty consistent. So what's kind of going on here is that he's just running these random walks, basically using random numbers that we talked about and these classes as kind of a drunken man kind of moving around a field, right? It's like kind of just identifying through like random simulations. And I think is what he's going to get to eventually, like, with machine learning, is that we can take these kind of walks, these simulations, kind of learn from them, learn their outcomes, and tailor, like certain scores and punishment and what is it? In like machine learning and artificial intelligence, it's like reward conditions, reward factors, or whatever, it's like training models and stuff. So it's probably going to start getting into that as this course starts to kind of break into machine learning towards the back half, which is pretty cool. So yeah, it's just kind of setting up in more of like a robust way, kind of an object-oriented way, right? You have drunks, a field, and then all these, like a location of a drunk, and then you have different types of drunks, right? You have this kind of base class, which have different types. One that has like a northward bias, one that just is completely random between left, right, down, and up. And so then you can just kind of predict the more steps they take, the further and further they get away. But with different types of drunks, there's different tailors or biases they may have to cause them to move further than others or whatnot. So he's just kind of showing these examples of like, simulating, data or real world, simulations in order to encode, I think, and trying to help kind of set this up for the future.
Libraries that you will surely end up using extensively in if you continue to use Python for research purposes. NumPy adds vectors, matrices, and many high-level mathematical functions. Actually, it might be NumPy, it might be NumPy, I'm not sure how to pronounce it, but we'll call it NumPy. So these are really useful things. SciPy adds on top of that a bunch of mathematical classes and functions useful to scientists. Things like, well, we'll look at some of them as we go on through the term. Matplotlib adds an object-oriented programming interface for plotting. Anybody here use MATLAB? Great. Well, you'll find that Matplotlib is think MATLAB, lets you in Python use all the plotting stuff that you've come to either like or hate in MATLAB. So it's really convenient. If you know how to do plots in MATLAB, you'll know how to do it in Python. Pylab combines all of these to give you a MATLAB-like interface to Python. So once you have Pylab, you can do a lot of things that you would normally want to do in MATLAB. For example, produce weird-looking plots like this one. All right, I'm going to show you one of the many, many plotting commands. It's called plot. It takes 2 arguments, which must be sequences of the same length. The first argument is the x coordinates. The second argument is the y coordinates corresponding to the x ones. There are roughly 3 zillion optional arguments, and you'll see me use only a small subset of them.
All right, so we'll go.
It plots the points in order. First the first xy, then the second xy, then the third xy. Why is it important that I say it plots them in order? Because by default, as each point is plotted, it draws a line connecting one point to the next point to the next point. And so the order in which they're plotted will determine where the lines go. Now, we'll see as we go on that we often don't draw the lines, but by default, they are drawn. Here's an example. You start by importing Pylab. Then I've given x vals and y vals 1. And if I call Pylab.plot of x vals, y vals 1, here is one of the arguments I can give it. I'm saying I'd like this to be plotted in blue, B for blue, and I'd like it to be plotted as a solid line, a single dash. And I want to give that line a label, which I've said is first. Y vals 2 is a different list. I'll plot it again. Here I'm going to say I want a red dotted line. And
We've used matplotlib before, so this is pretty
And then after plotting it,
simple.
I'm going to invoke pylab.legend, which puts this nice little box up here in the
getting
corner.
these
in
notes
case,
jotted down for you guys.
saying that first is a solid blue line and second a dotted red line, or a dashed red line, I should say. Now, again, there are lots of arguments, lots of other arguments I could have given plot. Also, legend, I can tell it where to put the legend if I so choose. Here I've just said put it wherever you happen to want to put it, or Pylab wants to put it. All right, so a very simple way to produce a plot. There are lots of details and many more examples about plotting in the assigned reading. We posted a video that Professor Grimson produced for an online course, 600.1x. It's about a 50-minute video broken into multiple segments about how to use plotting in Pylab with a lot more detail than I've given you. You'll see if you read the code for this lecture, and as you see this lecture, there'll be lots of other plots showing up of different kinds. These are my 2 favorite online sites for finding out what to do. And of course, you can Google all sorts of things. That's all I'm going to tell you about how to produce plots in class, but we're going to expect you to learn a lot about it, because I think it's a really useful skill. And at the very least, you should feel comfortable that any plot I show you, you now, obviously not right now, but you will eventually know how to produce. So if you do these things, you'll be more than up to speed. All right. So I started.
Oh, he has an example here, even better. Ooh. Oops. Here we go. So import Pylab. He's got values here. Right. I'll take these. Right, very similar. Then Pylab.plot x values, y values, legend. So this will do Pylab.plot x values, y values 1, and then we have it be blue with a solid line. Then we have label as first in the legend. Then we have a y values 2 input that we're also going to match to the x values. We're going to plot that onto the same plot object, the Pylab.plot. We're going to have this be red with dashes, and then have this have a second label in the key. And then we're going to apply the legend to the Pylab object. Okay. So let me take a screenshot of the graph. Copy that image. Paste that there. Cool. These notes can be found, like I mentioned, on my GitHub for you guys and in my Discord.
Started by saying I wanted to plot the trends in distance. And they're kind of interesting. So here's the usual drunk. and the masochistic drunk. So you can see, sure enough, the usual drunk, this fuchsia line, is progressing very slowly, and the masochistic drunk considerably faster. I looked at these, and after looking at those two, I tried to figure out whether there was some mathematical explanation of what was going on, and decided, well, it looked to me like the usual drunk was moving at about the square root of the number of steps. Not so odd to think about it if you go back to old Pythagoras here. And sure enough, when I plot, and I ran this simulation
remember,
up to
because
100,000
the
steps.
square root of a squared plus b squared equals to
root
c.
of the number of steps, it's not identical, but it's pretty darn
close. Because you have those squares
Seems
that
to be moving
are
at
applied
just
to the
a
a and b
tad
coefficients.
faster than the square root, but not much. But who knows?
But it's all nested under that square
pretty
root, so
good.
it pretty truncates
And
it pretty
then
close right down.
The masochistic drunk seems to be moving at a
Pretty
rate
linear.
of num steps times 0.05.
Actually, no, it's 0.05 because it's
Kind
half.
of a less intuitive answer than the square root.
Or not even half. It's like
Why
way
do you
less.
think it might be doing
5%.
that?
0.05.
Well, what we notice is that, and we'll look at this, maybe there's not much difference between what the masochistic drunk and the usual drunk do on the x-axis, east and west. In fact, there shouldn't be.
Yeah.
But there should be a difference on the y-axis.
Yeah, because the
Because
mouse
every
has
time,
weight and bias towards the north.
1/4 of the time, the drunk is taking a step north.
It's a little bit more
1.1 units.
than the
And 1/4
usual
of the time is taking a step south
of negative
of 0.9 units. And so half the time, the steps are diverging by a small fraction. And if we think about it, 0.1 half the time,
minus 0.9,
we divide it, we get 0.05.
0.05.
Okay? So
That's where that number comes from.
there's at least, we need to do some more analysis, but the data is pretty compelling here that it's a very good fit. Well, let's look at the ending location. So here you see a rather different kind of plot. Here, I'm showing that you can plot these things without connecting them by lines. So, and giving them different shapes. So what here I've said is that the masochistic drunk, we're going to plot using red triangles. And the usual drunk, I'm going to plot using black plus signs.
Rip Twitch game. Forgot about
And
it.
since I'm going to plot the location at the end of many walks, it doesn't make sense to draw lines connecting everything. Because all we're caring about here
is one final point.
The endpoints.
And they don't have any
So
relation
since I only
to
want the
like,
endpoints,
the inner steps, right? So we don't
I'm
want to
plotting them a different way. So
Just a
for
scatter
example,
plot.
I can write something like plot
dot scatter.
x vals, y vals, and then if I do something like, let's see, dash B0, or just B0 in fact, what that says is plot blue circles. I could have written, in fact, I did write K plus, and that says black plus signs. And I don't actually remember what I did to get the triangles, but it's in the code. And so that's
Hey,
very
Blinkers, how's it
flexible
going,
what
my
you
guy?
do. And as you can see here, we get the insight I communicated earlier, that if you look at east and west, not much difference between this ball and that ball, right? They seem to be moving about the same spread, the same outliers. But this ball is displaced north. And not surprisingly, after 10,000 steps, you would not expect any of these points to be below 0, where you'd expect roughly half of these points to be below 0.
Yeah.
And indeed, that's about true. And we see here what's going on, that if we look at the mean absolute difference in x and y, we see that not a huge difference between the usual drunk and the masochistic drunk. There happens to be a distance, but a huge difference
in the y.
X and x. Comparing the two y values, there's a big difference.
Yeah.
As you see here. So what's the point of all this? It's not to
They're
learn
all
about
relatively in the
different
same
kinds
X
of drunks.
grouping, right?
It's to show how by
That Y grouping's
visualization
almost
we can get
500
insight
units
into our
greater.
data. That if I just printed spreadsheets showing you all of these endpoints, it would be hard to make sense of what
Hey,
was
Veer,
there.
how's it going?
So get
We're at MIT
accustomed to using
6002
plotting
right
to help
now.
you understand data.
Lecture 5.
All right. Now
Fields
let's
of
play a little
wormholes.
bit more with the simulation. We looked at different kinds of drunks. Let's look at different kinds of fields. So I want to look at a field with what we'll call a wormhole in it. For those of you of a certain generation, you will recognize the TARDIS. So the idea here is that the field is such that as you wander around it, everything is normal, but every once in a while you hit a place where you're magically transported to a different place. So it behaves very peculiarly.
So you have initially with a number of
So
holes.
let's call this an odd
range,
field. Not odd numbers, but
100 by
odd
100 grid.
range.
Right.
So it's going to be a subclass of field. We're going to have a parameter that tells us how many wormholes it has, default value of 1,000. And
Okay.
we'll see how we use X range and Y range shortly. So what are the first thing we do? Well, we'll call field underbar init to initialize the field in the usual way. And then we're going to create a dictionary of wormholes.
Okay.
So for W in the range number of wormholes, I'm going to choose a random X and a random Y.
Between the negative X
In
range,
X range,
and a positive X
minus
range.
X range to plus X range, minus Y range to Y range. So this is going to be where the wormholes are located.
Should be X range
And then
plus
for
1.
each of those, I'm going to get a random location where you're, in some sense, teleported to if you enter the wormhole.
Or does random include the actual?
So here we're using random to get random integers. We've seen that before. And so the new location will be the location of the new X and the new Y. And we're going to update this dictionary
So
of
for every
wormholes
wormhole,
to
we're
say
going to get
that
an X
paired
and a
with the
Y
location
value,
X,
which is
Y
a random value between the X and Y
is
range.
new loc.
Or we then get new X and new Y, which is a random value between the X value and the Y range.
Now when we move the drunk,
And we assign
and again, this is just changing,
new location,
we're overriding
a location
move drunk,
as
so
new
we're
X, new Y.
overriding one of the methods
And then
in
on
field.
the XY wormhole index
So
tuple,
field.moveDrunk
we're going to assign that new location.
will take a self and a drunk.
So we're just creating 1,000 random wormholes with a random
It's
location.
going to get the X value,
Okay.
the Y value, and if that is in the wormholes, it's going to move the drunk to the
So it's gonna-
location associated with that wormhole.
It's going to check then
So we
if
move a
that
drunk,
XY
And if the
tuple
drunk
is in
ends
the
up being in the
wormholes.
wormhole, he gets transported.
Then we're going to assign
we're
the drunk a
using
new location
field.moveDrunk.
of the wormhole location.
So notice that we're using the move drunk of the superclass,
We're just creating like a random
even though we're
mapping
overriding
that
it here.
if
Because we've
a drunk
overridden it
happens
here,
to hit
I have
a
to say
place
field dot to
on the
indicate I
field
want the one
that
from
also
the
correlates
superclass,
to
not
a
the
wormhole,
subclass. And then
then it
we're doing
transports you to
something
that random
peculiar
mapping
after the move.
value. Pretty simple.
So interestingly here, I've taken, I think, a usual drunk and plotted the usual drunk on a walk of 500 steps, one walk, and shown all the places the drunk visited. So we've seen three kinds of plots, one showing how far the drunk would get at different length walks, one showing all the places the drunk would end up with many walks of the same length, and here a single walk, all the places the drunk visits. And as you can see, the wormholes produce a profound effect, in this case, on where the drunks end up. And again, you have the code. You can run this yourself and simulate it and see what you go. And I think I've set random.seed to 0 in each of the simulations in the code, but you should have play with it, change it to just see that you'll actually get different results with different seeds.
Okay.
All right. Let me summarize here and say the point of going through these random walks is not the simulations themselves,
how we built them.
How we built them. That we started by
We don't
defining
care about
the
the
classes.
drunk. He wanted to, like I said earlier,
We then
the
built
point of
functions
understanding the
corresponding
simulation
to
itself.
one trial, multiple trials, and reported the results.
Of like as a whole, like what we're doing.
And then
not
made a
the
set of
individual
incremental
simulations.
changes to the simulation so that we could investigate different questions. So we started with a simple simulation with just the usual drunk and the simple field. And we noticed it didn't work.
Hey, Ron, how's it going, dude?
How did we know it?
Poor
Well,
drunk.
not because when we did the full simulation, we had great insight, right? I probably could have fooled half of you and convinced you that that was a reasonable answer. But as soon as we went and did the sanity check, where we knew the answer, we could know something was wrong. And then we went and we fixed it. And then we went and we elaborated it at a step of a time. I first got a more I shouldn't say sophisticated, a different kind of drunk. And then we went to a different kind of field.
Yeah.
Finally, we spent time showing how to use plots to get an insight. And in the remaining few minutes of the class, I want to go back and show you some of the plotting commands to show you how these plots were produced. Since I knew I was going to be producing a lot of different plots, I decided I would actually not spend time worrying about what kind of markers, those are the things like the triangles and the plus sign, or what colors for each one individually, but instead I'd set up a style iterator that would just return a bunch of different styles. So once and for all, I could define n styles, and then when I want to plot a new kind of drunk, I would just call the style iterator to get the next style. So this is a fairly common kind of paradigm to say that I just want to do this once and for all. I don't want to have to go through each time I do this. Get this window. Oh. So here it is.
So we have a style
So there are gonna
iterator
be
of
three
m dash,
styles
b dash dash,
that I'm
G
going to
dash.
iterate through. Style 1 is going to be an M, I guess
Magenta.
that's maroon, with a line, a blue with a
dash.
dashed line, and green with a line with a comma and a minus sign. So these
Comma and a
are called the
minus
styles, and you can control the marker if you have a marker.
What?
You can control the line, you can control the color. Also, you can control the size. You can give the sizes of all these things. What you'll see is when you look at the code is I don't like the default styles things because when they show up on the screen, they're too small. So there's something called RC params. Those of you who are Unix hackers can maybe guess where that name came from. And I've just set a bunch of things, like my default line width will be 4 points. The size for the titles will be 20. You can put titles on the graphs. Various kinds of things. Again, once and for all, trying to set some of these parameters so they get used over and over again. here, you'll see that I did things like you want to put titles on the slides. So on the graph, so here's the location at end of walk. Title is just
Legends.
a string.
Okay, this is just basically
you
showing
want to
us
label
like
your in the
Matplotlib
here is
stuff.
not is that you don't. There's almost surely a way to make it do that. We'll move on, and in particular, we'll look at walks. Next lecture, we're going to move on. No more random walks. We'll look at simulating other things, and in particular, we'll look at the question of how believable is a simulation. See you Wednesday if the world has not come to an end.
What happened Wednesday of 2017? May of 2017 on a Wednesday. I was graduating high school around this time. All right, sweet, you guys. That was lecture 5 of MIT OpenCourseWare, Introduction to Computational Thinking and Data Science from their 2016 Fall 6.0002 course. That was a lecture taught by Dr. John Gutag. So really awesome. I really like John's lectures. I think he's a funny, cool guy, and he does a really good job of kind of explaining things in like a nice object-oriented way. And I like his clean code. It's pretty fall 2016. Oh yeah, right. So it was uploaded back in 2017. This is back. So this is fall 2016. Oh, gotcha. So he's referencing the 2016 United States election, I guess. Tim says. Tim is smart. All right, you guys, let's throw a like on that. If you guys are here with me, throw a like on the stream. If you guys enjoyed watching that with me, I'm recording this right now, so I'll upload this back to the channel. I just uploaded the lecture 3 watch along, so go ahead and check that out if you are behind on the follow along series. The lectures are really awesome, and I'm recording myself, kind of reacting and watching them, so you can watch them with a peer rather than watching them just alone. I think it's a kind of a cool new resource that I haven't seen a lot of people do ever, so hopefully it kind of picks up some traction on YouTube. Anyways, thanks so much for you guys being here and joining me tonight. I might hop back on a little bit later after I take a short break here to go ahead and, well, let me get an outro actually for this video. So thank you guys so much for watching this MIT 6.0002 Lecture 5 Random Walks from the MIT OpenCourseWare from fall 2016. We will be back with Lecture 6 in the next one. Thank you guys so much. All right, cool. We will go ahead and stop the recording. Boom, 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 boom. Nice, that recorded. So unfortunately, I did record 2 of the Python Crash Course Try It Yourself videos for you guys, and my video files like corrupted or something. They're all glitchy. They did not render or remux properly. I don't know what happened to them. So I'm going to have to re-record those, which is really annoying. They did take me about 20 minutes each to record. They were a little bit longer problems, they were easy problems, conditional like problems, going over like conditional operators, but they just wanted you to give a lot of examples for each conditional operator and stuff. So super big bummer. I'm pretty pissed that it was pretty annoying, actually. It's honestly really frustrating. But I will go ahead and try to re-record those for you guys and get those out soon. But I have uploaded up to Lecture 3 for the MIT Watch-Along series. I'll go ahead and record or edit number 4 and then this one, number 5, and put that out this week. So we'll be all caught up to this point. And then I do need to go back through in the Discord and make the post for the weekly breakdowns. So I am behind on that. I'm sorry. Thank you guys so much for bearing with me. I'm behind always on keeping up with the content. But it gets hard doing a full-time job, trying to stay sane with, at least taking some time to have some personal time, and then also streaming every single day. It's pretty tough, you guys. And then also getting like YouTube content out for, consistently. So anyways, I appreciate you guys being here and joining me today for this lecture watch along. I'm learning a lot about, classes. I'm actually very, I'm getting, what I'm really, picking up, I'm not getting like a lot of like, new, like a lot of this stuff is kind of more review. Like we've already done a lot more of this object oriented. We've done matplotlib stuff. We've built full on plots, our own custom plots using our chromatography and spectroscopy simulations and whatnot. But I am learning a lot more about, the ins and outs of kind of listening to someone else's code and following along. I find that I had difficulty in the Harvard CS50X course, reading the problem set and like jumping into someone else's code and understanding what was going on. And as I've been reading through and following along with John and with the other professor, Eric, Professor Eric, and they've been showing their code examples and their object examples live on the stream or on the lecture. I've been able to really like follow along, actually understand what these objects are doing and what their methods are doing pretty easily. Now it does help that their code is pretty cleanly written, right? And so it's pretty easy to follow along. Tim, look, 2016 general election images of Pythagoras note in Maine, Donald Trump truthometer, the TARDIS. So they had a Donald Trump image on here. That's funny enough that they would have that. Speaking of the reference they made in the lecture for the 2016. Isn't that funny, Tim? Anyway, you guys, I'll probably I might come back on a little bit later to do some project work, but I'm going to be keeping consistent this week, you guys. I'm going to be streaming every single day this week, Monday through Friday, like I have been normally, and we're going to keep going on with our projects and the course. We're going to be doing our longer streams, like 7 to 9:30 or so. So pretty cool. All right, thank you, Polyron. I appreciate those kind words, and you're awesome. Thanks so much for chatting with me today. Anywho, you guys, please like the stream if you're new and are liking the content so far. We'll be back tomorrow with lecture number 6. And then after that, I believe we will move on to, let's see here, the assignments. You have problem set 1. Okay, let's go to syllabus. Okay, problem set 2 is due. So problem set due is on week 6. So we probably need to do problem set 2 before we watch. No, I'll keep it 3 and 3. So problem set 2 is out now, and problem set 2 is due at the start of lecture 6. So we might need to do problem set 2 before we do Monte Carlo simulation to follow the schedule. Or I guess it doesn't really super matter as long as we do the problem set 2 before we move on to week 7. East Coast gang not coming back for real. What's going on with the East Coast gang? Great idea, Parker. What's a great idea? Hey, Parker. All right, so we'll watch the Monte Carlo simulation tomorrow. We'll do every 3 lectures. So 3 lecture, 3 lecture, and then we'll do the problem set 2. And then we'll do this one and this one. Then we'll do problem set 3. As long as we get it all done, it'll be all right. But we're moving along pretty quickly here, you guys. So for just a refresh for those that are new here, for our projects, we're working on a project called Better Options right now, which is just an object-oriented approach about extracting out finance information, extracting out option chain, if you guys are familiar with options trading, and then kind of using some models and simulations to identify. My goal is to cross-reference some certain options of interest across different models, such as like the Black-Scholes model and some other simulations, to project kind of value weighting or ratings to these option contracts. So like I would like to give it like a score almost of what I believe the option could be successful or not. So like, let's, for example, in my testing py here, if I run this, expiration index 81 option change. Okay, let me just do this. There you go. So as you can see, like what's this displaying is the current option strike price. So the what? Oh, yeah. Let's try it again. So what I'm doing is I'm extracting out some information here, and I'll show you, like, I'm getting the option strike price, so the 110 option strike price. The current price of the contract is 92.55, and the Black-Scholes model price is 92.5 for a negative 0.05% change. So this contract is fairly valued. Whereas if we look at some of these other contracts, like for, this is giving the ticker of Apple here. So Apple's current strike is around 205 is current price, like 203, 208, somewhere around there, 205. So the at the money contract is like around here. And as you can see, these contracts are worth $3, $2, and $1, 150, whereas their values are pretty are have a negative percent change associated with their Black-Scholes value. So these contracts aren't really, you know, in the eyes of this, super valuable. Now what I'll do is I'm going to increase this out to be the, like, you know, 10th expiration date in the options chain. Now, because the Black-Scholes model better predicts options with longer dated, you know, expirations. So if we look here at the Apple 200-205 call, well, the Black-Scholes value of this contract is actually 16 and the 210 is 14, whereas the value of the current contract is at 14 and 12, giving you a positive change compared to the Black-Scholes value of 12 and 14%. So in the eyes of the Black-Scholes model, these Apple kind of longer dated contracts are actually pretty undervalued, and could be a good option to kind of look into more. And you know, you can see that actually a lot of these options for Apple are giving positive indications on the Black-Scholes, and some pretty heavily positive indications here, towards these kind of more, a little bit further out of the money. But I don't want to go too far out of the money because, you know, you go, it's just you get wrecked by the Greeks, and we don't have any of those factoring into our math at the moment. So well, like, that's going to be another one of our weighted checks, is kind of evaluating of the Greeks in certain kind of ranges, which are Greeks are the kind of the mathematical calculus values, like derivatives and whatnot, and you know, of these kind of parameters that affect how the contract moves, and it kind of gives it its life, basically. So now it's still very rough. We built this in literally like one day, right, in one stream sesh, and so we built a lot in that stream session. But what I'm going to do is, you know, have like an entire kind of, maybe like an interface, but it might be in the terminal for right now, to not only, you know, take the, let's say we're looking at the Apple 210 option for this expiration index of 10. You know, the further out of the expiration index you give, just by Y Finance, the further, you know, the 0 index is the expire option that expires the closest, right? So the 10, this one is a little bit further out, you know, like 50 would be way out in the future. And so the Black-Scholes model, works a little bit better with further out options. And so you can see that Apple is pretty, has some discount opportunity here, given its price movement, and it kind of does make sense given the current price movements of Apple. Like if we look at Apple, it had a really good earnings report, posted a really good income statement and balance sheet, double beat on their earnings, and projected out some AI improvements, but yet their stock dropped about 2%. So it does make sense that this Bulls model, this Black-Scholes model, is projecting that these options are kind of undervalued right now. And so what we could do is take these options of interest, cross-reference them against a couple of other models and other indicators, provide a general weighting or score to the contract, and that'll give us a better idea and better confidence in investment strategy, I think. So I think it could be a cool idea to go down, and we've got a good structure here to kind of play around and we've got a good object-oriented way of messing around with this, and so we can easily just start adding in different methods as these kind of models, financial models, quantitative models to do these simulations on, and then we can kind of compile them together and figure out some sort of approach to give them like a weighted average, right? To be buying. Thanks so much for Indranel. Thanks so much for the this says this looks really good. Let me know what you guys are building. What do you guys have? What's some of the stuff that you guys have been building lately? What's some of your guys' projects you guys have been working on? Give yourself a shout out right now. What have you guys been studying, working on? Let me know here. Let me know. What are you guys working on here? Right, so like this 250, this 210, 215 option at like 16, it's pretty good, right? They're just expensive though, right? They're just expensive. You got to be willing to put up, 1200 bucks for a $1,400 for a $200 increase. So you got to be willing to put up 1200 bucks on an option contract for a 14% potential gain, right? Which is a little bit risky for a 10-day out expiration index. Now, what exactly is the expiration date? I'll need to print that out directly. Finance tracker app, nice. Yeah, we kind of have a similar thing in Dronell. We have a whackathon, so this is our community project right now. You guys can all participate in this and add code if you would like to. I have it open to you guys. It's kind of like our first kind of open project right now, where you have the ability to kind of load in stock accounts, right? So you have various accounts such as individual taxable account, a Roth IRA account, and you can populate and view the various positions within that account. And then you can also see, all of the accounts and get a total view of all the positions, and that'll give you kind of an overarching net worth view. So as you can see with this dummy data, we have a total value of all of our accounts of just over $5,500. And so that would total like an entire net view of our entire account or our portfolio or net worth, right? So I currently have it just working for the accounts page here right now. And then you also have the ability to view positions, such as, so it'll view, you can filter out various tickers. So I'll say, okay, I'm going to, in this certain account view, I only want to view tickers for Microsoft. And there you go. Now I can reset and bring it back to the view for this account, or I can go back to all accounts, right? And get the all accounts view. Or I could search for just Roth IRA, and that'll show me only the Palantir position. I can search for only Microsoft in here. No positions were found. I can search for only the Palantir, even though it's only the one in there, right? It'll say position found, updated. I can add a position to this account, Roth IRA. Let's say we're going to add in a position of Microsoft for 1 share at an average cost of 0. We say we got it for free. We add in 1 share of Microsoft. There it goes. And we can say all accounts, view. I think we do have a bug. Yeah, I think we do have a bug. Yeah, we got a bug. No. I think it's because we added multiple Microsoft positions within the same account. So it's detecting two Microsoft positions, right, within all of accounts. And it's not knowing what to do with that secondary Microsoft position. So if I add a position to the individual here for, if I did Palantir, right, because that one's in the Roth IRA, and added that, and then I look for all accounts search, I get that error again, right? Because I think it's because it has duplicated position by ticker, but not actual objects, right? So we'll have to fix that bug. Yeah, we got to fix that bug. I haven't worked on it in quite a while though. I've been working on the MIT course. All right, you guys. So join me tomorrow where we'll continue on by watching Lecture 6, the Monte Carlo simulation, and probably jump in and take a stab at problem set 2 and getting that going tomorrow. So make sure you guys are here around 7 p.m. PST, and make sure to subscribe and follow along to the channel and like the stream if you are enjoying the content. I'm gonna upload like Python crash course videos this week. I'm gonna try to record like a 1 year coding breakdown to show kind of what I've done in 1 year, kind of showcase my projects all together, and whatnot. So thanks so much for being here. We'll be continuing on with tomorrow, and I'll see you guys tomorrow. Thank you guys so much. Bye. Have a good one. Oh, by the way, Counter-Strike stream at 3K subs. We're going to do a Counter-Strike stream and case opening stream at 3K subs. So make sure you guys subscribe and, be on the lookout for that. So thank you guys.